So, hello. Well, I'm William, and I'm here today to talk about your proposal on how to take your transactions history and balances from your nodes and how you can do it. First, a quick introduction. Oops. Quick introduction about myself. I created AutoScan over 2 years ago. Who here in the audience knows what the AutoScan is? Yeah, good. Well, for those who don't know, WaterScan is a self-hosted block explorer that you can run at your own home. But today, I'm not going to talk about that specifically. I'm going to talk about what I think is the next big thing that will bring real usage through Ethereum clients. Uh, we don't think that begging people on Twitter to run their own nodes is enough reason for that, or expecting that they will just run nodes to help the network. That's not enough motivation, right? I think the answer is actually very simple. We need nodes to provide data that users actually want, something useful for users. And we think that we are failing miserably on that mission. In order to illustrate that, I'd like to tell a quick history about personal history. Back in 2018, I came in contact with Ethereum, and the first thing I tried was to run my own node. I heard of something called Miss Wallet. I guess most OG guys know what it is, and I decided to install it and sync my own node. Some hours later, I just gave up because it was taking so much time and I didn't understand why it was taking so long. Maybe I was doing something wrong, but so I just decided to use some hosted service, which in 2018 meant using just Infura. Okay, great. A few clicks later, and I got the test node working, and then came my second disappointment. I did some test transactions, some transfers, then tried to find a way to search for my own transactions. And just to discover that the standard API, besides using this thing called JSON RPC that no one else uses, also don't have such a basic feature. So back to today, what's the scenario? Well, selling APIs has become a business. We have many offers from different vendors. Every node provider has its own proprietary implementation. And this is bad for consumers. You have vendor locking for each proprietary API implementation. Uh, well, the scenario today is it's basically the same as 5 years ago, but now you can pay a little for closed source solutions. We think this is wrong. And what is our proposal? We have published a new API spec for what AutoScan would need in order to support getting users' token balances and transfers. And we have published what we call AutoScan API v2. And the design of the API was driven by AutoScan requirements, but the end goal is not to be AutoScan opinionated, so that's why we are publishing it right now and try to gather feedback from the community. It consists in a new set of custom stages that will generate all those data inside the Aragon database. So it's a reference implementation inside the Aragon. And for right now, it has already very low overhead, even though it's not, the code is not optimized, the size, the database format is not optimized, but still, it takes over 1 day to moderate hardware to generate all this data the first time, and also the disk space is about 60 gigabytes, or over 3% of standard archive node for mainnet. So now let's take a quick look at how this API works and what does it provide. First, we have what we are calling the contract classification framework, which is a custom set of custom stages that will take all deployed contracts and classify them. And let's say, okay, there's a contract deployed, it's an ERC20, ERC721, or it's a minimal proxy. That's what it will do. For now, there's a small set of classifiers, but it's flexible for you or for us or for anyone to create new classifiers and plug it into the sync loop. This is an example on how it works. Here is an example for getting the ERC20 data. So first we have a count method, which gives you, let's say you have a mainnet nodes, how many ERC20 tokens it has identified. And you have a second method, which gives you a list of ERC20 contracts. So you have a zero-based index and page size, and it gives you the token addresses. And this is how it looks inside DappCon. It consumes this API and shows this fancy. There is a new contract explorer page where you can see in real time all the contracts being deployed, and in this case, all the ERC20 tokens that it identifies. But of course, it's an API, so not only others can use it, but your own software can make use of it, like you, for example, use some proprietary ERC20 API from some node provider. And we have variations of these methods, count and list for right now for ERC20, for NFTs, for ERC4626 volts, and ERC1167 minimal proxies. The second feature we have now is the token transfer search API, which gives you, given an address, all the transfer transactions associated with that address. So if you receive or you send any token, it gives you the transaction list. So again, we have the transfer count method where you pass an address, and then you have the transfer list where you pass the address, zero-based index, and page size, and it gives you the list of transactions. It's important to say that the search results are per transaction, not per block. So it scales no matter if the chain you are scanning has big blocks or smaller blocks. You get paginated search results per transaction. And this is how it looks like inside DappCon. So it consumes this API and shows you this fancy paginated search results list. And the third feature we have for now is getting token holdings per address. So giving any address, for example, your personal address, it gives you which tokens you hold. And by you hold, I mean which tokens have some transfer event associated from or to that address, no matter which token. And the problem we are trying to solve here is there is an infinite number of tokens deployed inside your mainnet, for example. So in order to get the balances for your address, Worst case scenario, you would have to iterate over all those tokens and get their balances. So this is kind of a filter. You get all transfers associated with your address, and then in a second step, you can query the balance themselves. And this is how it looks like inside DotterScan. This is, by the way, for Vitalik address, so there is a lot of spam tokens that are already hidden, but there is a hard-coded list of white list of token addresses, and we use this API to get this list, and then we query each one in a timely manner. So now about the future of those APIs. Well, even though it already works very well, does not take a lot of time and a lot of disk space. We think that there's still room to optimize it. We may explore using the Aragon 2 torrent snapshot format, so users can, like for example, nowadays when you install Aragon, it downloads the headers, blocks, and transactions via torrent. So we may implement something like that for those indexed data. So you don't need to regenerate it from scratch every time. So you can just download some pre-made static files, and you just run it to the tip to complete the data. We want to expand the available indexers, so there's a small set building. We want to make more, depending on what is interesting for authors to display in their interface. But we also want to allow users to plug their own indexers, so we kind of want to make some stable public API. It should be possible to hack the existing code to add your own indexers, but it may require using some of the internal code of Aragon that may change in the future. So we kind of want to make some stable interface so users can make their own indexers. They can eventually try to push via PR to AuthorScan, or they can keep it for their own. We want to make it easier to hack Aragon code in practice. As a small gift for you who are here watching this presentation, there is a test node. So if you want to try those APIs, just please don't DOS it, otherwise I would have to take it down. And that's it for now. Thank you.
Thank you. Are there any questions for William?
A couple questions. So the first one is which chains it runs on, and second, how do you handle, like what you briefly mentioned, all those spam coins and currencies? So yeah, even not being Vitalik, you can get like a couple hundred of different spam. So how do I, and they often look like legitimate ones, even with the names and everything else. How do I look at it, see the value, and can distinguish between the different ones? And how can I be sure of what I'm seeing and what the data? Because if some scam says that I have 200 ETH, but I don't, and then I interact with that, not so much.
Mm-hmm. Well, it should work with any chain that Aragon syncs, which means right now is all testnets, mainnet, Gnosis, Polygon. But for this version, I have it only tested in Sepolia testnet and on mainnet because of lack of time. But it should work. If it doesn't work, you feel free to open an issue and I'll try to investigate it. And about that second question about the spam tokens, right? Well, it depends on which classifier you are talking about. For example, for ERC 721, it requires ERC 165. So if we try to, what we do is we instantiate the EVM inside the Aragon stage, and we load the contract into the state, and we call the EVM and calling the support interface, which is the ERC 165 standard for the NFT standards. So if it returns the expected results, we say, okay, this is an NFT contract. For ERC20, it's more complicated because there is no standard. It does not implement ERC 165, so we try some kind of duck typing. So it's kind of a risk. So we instantiate the EVM, we load the contract, and we call the methods name, decimal, and symbol. And if the result is something like look like a string, okay, this is an ERC20 token. But even so, there's a lot of faulty contracts that they return some junk on the string results, right? So we have some not so beautiful codes that tries to filter and remove those junks of it's junky. Okay, this looks like an ERC20, but it's actually not. We were able to do a good cleanup in the current code, but there's still some false positives that we are trying to make it go away automatically.
Thank you.
You mentioned that you could add your own indexing. Is each index its own index, or does it all share a list of addresses and then have attributes that I can add to that index? Because it seems to me a lot of the ERC 721s are also 20s, so you wouldn't have two separate indexes. Is that true, or no?
Yes. First, there are two kinds of major data structures. First is the contract classifier. So, given address, given that code, which properties this code have. So it can be a ERC20, it can be a ERC 721, it can be a minimal proxy, and some attributes can occur simultaneously. And there is the second major data structure, which is relating this some address with some of these major contract types. So occurrences of this address in the context of an NFT transfer. So this is another separate data structure. And you have multiple occurrences of this data structure. So you have transfers for ERC20, transfers for ERC21. You may have other kinds of data structures which we still don't have, but I think it will be useful. But that's how the code is right now. Like I said, it's not optimized. I'm still unsure if some of those data structures could be collapsed and more optimized way. But for now, I'm still trying to see the whole picture, driven by the needs of AuthorScan. So that's why it didn't bother me to optimize it a lot, but actually first make it work how, as a user, I want it to be.
Anyone else? No? Okay, so thank you, William. Thank you very much.
Thank you.